This video shows how to do the computer project associated with Unit 5. Instead of the chirp and temperature data, though, I'll use data taken from the StatLib database available at Carnegie Mellon's website, specifically a few values from the body fat database, giving several body measurements on over 200 men. But I'll use just two measurements, thigh and biceps circumference, on 21 men. These two values should be strongly associated, but it's hard to see that one causes the other. For no good reason, I'll put thighs on the x-axis and biceps on the y-axis. Again, I copy and paste the data into a spreadsheet, Excel this time, thighs in the A column and biceps in B. Then I highlight both columns of data and insert a preliminary scatter plot, for now using the format with just dots, no connecting lines. In a Google Docs spreadsheet, to get the option of a scatter plot, I click on the Chart button and then on More. I'll need to move the chart to the right to clear columns C and D because I'll need them later. Then I can answer question 3. I can put the averages and standard deviations at the bottoms of the data columns in the same way as on the Unit 3 project. Maybe this is a good time to mention that an open office spreadsheet has commands very similar to those in Excel, but the symbol to use between the arguments is not a comma, but a semicolon. The Excel function that gives the correlation coefficient, R, is correl, so I type equals correl open paren A2 colon A22, comma B2 colon B22, close paren. The slope and intercept functions give the slope and y-intercept of the regression line of biceps on thighs. For the correlation coefficient, it didn't matter which column comes first, but the slope and intercept functions want the y values first, B2 colon B22, and then the x values, A2 colon A22. Then I want to get the spreadsheet program to find the y values on the regression line for each of the given x values. Because I have the slope and intercept of the regression line, I can use them to type in the y values on the regression line for each of the x values of real data points. Equals B $26 asterisk A2 plus B $27. The dollar signs in B26 and B27 keep the numbers from incrementing when I drag down, as we did in Unit 3. I could also have done this column using the forecast command instead. It would have read equals forecast, open paren A2, comma, B $2 colon B $22, comma, A $2 colon A $22, close paren. Next, I need the y values on the SD line for each of the data point x values. Because the SD line appears only in our text and is not implemented directly in spreadsheets, I must do this one using the averages, SDs, and correlation coefficient. But I only need the sign of the correlation coefficient, and because it's positive, it doesn't appear in the formula. I solve the equation of the SD line for the y value and type the result into the cell. Equals B $24 divided by A $24 asterisk open paren A2 minus A $23 close paren plus B $23. Then I can highlight both cells C2 and D2, click on the lower right corner of D2, and drag down to get both lists of y values. Next, I'm supposed to make another scatter plot with 3 y values for each x value, so I highlight all 4 columns and insert a scatter plot, this time the format with broken lines joining the data points. In Google Docs, it's harder to get both data points and lines on the same graph. I would be satisfied with a line graph instead of a scatter plot at this point, but if you can figure out how to get both, great. Because I highlighted the column headers, the legend labels the 3 kinds of y values. But before I go further, I should move the chart to a convenient place and then clean it up a bit. When I right-click on the vertical axis and then click on Format Axis, I get a menu that allows me to change the scale. All the y values are between 25 and 40, so I change the maximum and minimum values on that axis from Auto to 25 and 40, respectively. Next, I want to take out the line joining the actual measured data points because those connections are meaningless. So I right-click on the blue line somewhere and choose Format Data Series. That will give a menu on which I can choose line color and no line. When I close the menu, the line disappears. Next, I want to get rid of the dots along the regression and SD lines because they are meaningless. I only care about the line, not the particular Y values on these lines at the given X values. Right-clicking on the red regression line and choosing Format Data Series gives the same menu as before, but this time I choose Marker Options and None. Then I can do the same thing for the green SD line, and finally answer the last question.